Hello, everyone. I'm John Lynn, the founder and chief editor at Healthcare IT Today. I'm excited to bring you an interview about a topic that's my favorite topic of all healthcare IT right now, which is really around the kind of ambient clinical voice and everything that supports it, NLP and all the technologies that need to make that happen. So my guest today is Raghav Mani. He's the product manager for healthcare AI at Nvidia. Welcome, Raghav.
Thanks for having me, John. Really excited to be here.
Yeah, so as I said, it's my favorite topic. But before we dive into it, tell us a little bit about yourself and NVIDIA. I think people are familiar with NVIDIA. They've probably seen it on their kids' gaming computers or their own gaming computers. But I think you guys are doing a lot in healthcare that some people don't understand and realize. So can you tell us a little bit about yourself and NVIDIA?
Sure, I can start with myself. And as you said, I'm a product manager for healthcare AI at Nvidia. And prior to Nvidia, I've been at Nvidia for about a couple of years now. And prior to Nvidia, I worked at Epic for many years. I, in fact, led the patient engagement team called MyChart for many years as well. So telemedicine is near and dear to me. I worked on many telemedicine projects when I was at Epic. And I also led the deep learning team focused on natural language processing for a couple of years, which is what led me to Nvidia, because Nvidia is the leader in AI. And talking now about Nvidia, NVIDIA has been in the healthcare space for quite some time. As you said, most people think of NVIDIA as graphics cards for playing games, but we've been leaders in AI for many years now, and we also have had a presence in healthcare for many years now. We think of the different products we do as being essentially a computational platform for healthcare, ranging from medical imaging to genomics to smart hospitals to drug discovery. And we have products and platforms in all of these different areas. Basically, anywhere where there's a tough computational challenge and healthcare and life sciences is filled with them, NVIDIA has technologies and products in those areas.
I think it's such a fascinating story that the GPU that used to do video processing now is basically powering most of the AI as we know it. So pretty awesome story. And so let's dive into some of that. But it's interesting your background in Epic, because I think that's where I want to start the conversation, which is what I call automated charting. People are calling ambient clinical voice. There's a lot of terminology that's being overlapped, EHR, AI assistant, whatever you might do. It's really exciting what's happening because every doctor wants to automate chart, right? I mean, it sounds like a beautiful thing, but where are we at in this whole, evolution to automate charting for healthcare?
Yeah, I would say in a way we are in the beginning stages, but I would also say the technology is actually mature enough to now be ready for production usage. So the reason I say that we are still in the beginning stages in some sense is because there is the amount of innovation that's happening in NLP specifically, in conversational AI broadly, but in natural language processing specifically, the amount of innovation that's happening right now is already showing us that as cool as the things that we're doing out today, there is so many more things that we could do as we push this technology further. So that's why I say, in a way, it's at the early stages, but it's also robust enough right now for many practical use cases in production settings.
I think that's the best description I've heard, is the technology is ready, but we just haven't finished the research and those types of things to productize it. That's a great description of it. But as you pointed out, though, what are some of the use cases you think that are going to be used for this, and the implications for patients and doctors of all this technology that's coming? It's kind of a confluence of technology in one area. What do you think the implications are for patients and doctors?
I think there are tons of positive implications, but maybe we should just define, what are the types of things that you could do with these new technologies. And I'm going to focus in on natural language processing, because all of the topics that we're going to talk about, I think you could broadly categorize it as conversational AI. And conversational AI, in my mind, falls into three underlying pillars. One is around speech recognition, this is like speaking and then the system automatically transcribing it to you. And the second piece is the natural language processing, which is to understand what is actually in the text and then do something with it. And then the last piece is the text to speech, where you synthesize something back. And I think personally, the most exciting developments are in the natural language processing space. And it is driven a lot by this a growth in new model architectures, new deep learning techniques that are producing much better performance than anything that you would have seen even 2 years back. So what used to be state of the art 2 years back, what used to be the way you did natural language processing just a couple of years back is totally different now. What that means is that a lot of different use cases that are centered around natural language processing have become suddenly, quite quickly, really, really powerful. So it could be, understanding what the sentiment in a body of text, or it could be if you want to extract information from text so that you can automatically fill in structured information in a medical record. It could be to automatically summarize a note, summarize a conversation into a succinct note. Those are all things that are very doable now. So given how the technology has evolved and how the technology can power these few different use cases, you can kind of see how it could really impact patient-provider interaction in a very positive way. So let's stay with telemedicine, because I think telemedicine has the added benefit that the technology for audio and video is already there. You don't need to put some new hardware to do that. The video stream and the audio stream are already running. So if you could just run these AI models on that stream, you could automatically, obviously, transcribe the conversation, which itself, I think, is a huge benefit for both the patient and the provider, just being able to document automatically. But you can go much more than that. You can automatically extract key information. So this would be relevant for the physician. They don't need to necessarily go into each of the specific places in the medical record and document it. It automatically files all the information. And you can also imagine how this could summarize the whole conversation for the patient, so that after the visit is done, they have a good thing. They have a good summary of what the conversation was. They didn't have to furiously write down everything that was being spoken to. So you can imagine how this impacts the patient experience. It's a much better patient experience. And then obviously it is much better for the providers as well. No doctor, as you said, wants to sit down and chart, right? If you can just automate all of the charting at the end of the visit, everything is already charted in such a way that you just have to review and accept. That, I would say, is the ideal that we could shoot for. And I think the technology is actually getting ready to be able to deliver that idea.
Yeah, I think it's so powerful for doctors, but I love the patient angle as well, which I think we don't see as being addressed as much, which is interesting. With your MyChart background, it's the perfect place to do that. Take all of that data from a 15-minute visit and just bubble up the stuff that really matters in a patient-focused manner, because sometimes that gets confusing as well. So anyway, that's a different interesting application.
And actually, there is again, the same NLP technologies can also assist with producing patient-friendly versions of clinical notes.
Exactly.
So just making patient instructions and clinical notes. Because then again, and MyChart, we did this open notes initiative where provider notes can be made easily available to patients. But one problem that you still can have is, how do you convert that into patient-friendly text? And the technology to even do that is the same core NLP technologies, and they are getting very powerful as well.
Yep, that's great. So let's dive into the research. You guys recently published a paper about this, and I think did a presentation, must have been a virtual conference, I guess, these days. And we'll certainly link to the research paper and the findings in the notes for this interview and in the article. But you guys published a paper looking at entity recognition and concept mapping from conversations. So that was the research description of it, but I would describe it as NLP, right? I mean, it's core NLP, identifying the right data that matters and what, in the context, and being able to use that, whether in our cases we've talked about for patients or for medical charting, whatever it might be. I think that's core to what we're talking about. But what did you guys find in your research that I think was novel, and what does it mean for healthcare?
Yeah. So I might have to just take a little bit of a step back and explain how the NLP evolution has happened in the last couple of years. Sure. One of the most important developments that has happened is this new type of deep learning technique called transformer architecture. And this new technique is the engine that's powering all this NLP work. So much so that all of this is people refer to this as the ImageNet moment of NLP. And it's a reference to how deep learning about 7 or 8 years back fundamentally transformed image processing and image recognition. And that was started off by this thing called ImageNet. In a similar way, this new model architecture and its derivatives are fundamentally transforming how you do natural language processing, so much so that it's called the ImageNet moment. So that's a bit of history. So our work is in that context. We are building upon this. There is a steady stream of research that is innovating on top of this new architecture. And oftentimes you might hear this term called BERT. BERT is a specific type of NLP model that is built on this transformer architecture. So our work is in that stream. Our work builds on the same methodology as BERT. What we have shown is that if you to produce a very good language model, which is a precursor to doing very good NLP, you need to produce a very good language model. To produce a very good language model, you need to train it on data that is similar, that is domain specific. So if you're in a healthcare setting, you cannot simply train on Wikipedia text and hope that that performs really well on a healthcare setting, in a clinical setting. So, and if you're in the same with biomedical data, if you need to do something well with biomedical data, you need to train it on similar data. So we showed that how if you train on a lot of domain-specific data, so and the key here is a lot of domain-specific data. We showed that if you increase the data a lot, the model performs significantly better. And if you train it for a longer period of time, the model keeps getting better. So we, over a series of experiments, we were able to show that if you increase the model, if you increase the data set size that from that particular domain, and if you also added, made the models themselves be larger, more powerful models, and then if you trained it for a longer period of time, the output that you get is a much more powerful language model, which in turn that you can use to build the specific NLP use cases. So the model that we released is called BioMegatron, and we think it is the state-of-the-art language model for biomedical and clinical use cases. But this is how it was built, by using a lot of data, by building ever larger models and then training it for a long period of time. And this is a lot of experimentation that goes into it. So it's not like you try it once and it works. But the net result is that it's a very high performing language model. But it follows in this is the sort of the historical trajectory. There's this new method of doing NLP, and people have been experimenting with it, including us. And as part of this experiments, we've been playing with more data, more domain-specific data, and we're able to see that that produces very good models.
And so, if I remember right, the data is coming from medical journals. Is that the largest source of data for your model?
That's right. So PubMed, which is an open, repository for biomedical literature, that's our main source. It is the model that we have released can absolutely be made even better if you were to train it on medical, clinical notes, for example. Okay. So if for example, a healthcare organization that has access to a lot of clinical notes can use the same approach and the recipes that we provide and create an even better clinical language model than the one that we have released. So I guess it goes into a slightly related point, is that the way we approach this is that our own research team produces these really high quality models. That's one way by which we enable the developer ecosystem. But another way by which we enable the developer ecosystem is providing the training tools so that they can use our models and then continue to make it even better on their own data.
I got you. So that was going to be my next question, is how could people use this? If I'm an EHR vendor, can I go and use your model and your technology to apply it? Obviously the EHR vendors have millions of records of data that they could train it on. Is that the right approach, or I guess it could even be a Nuance or an M-Modal or whoever it might be? Could they use that as well to train a model to do the NLP?
Yeah, we work with all of them. I mean, we work with EHRs, we work with Nuance and Sekara and Sukis of the world. We also work with the healthcare provider organizations and payer organizations. So our goal is to enable the entire developer ecosystem. And the developer may be at a provider or a payer or in an EHR or any other developer. And all of the tools that we provide are made freely available, so they can use it to make their own applications be better. So really the goal is to enable the entire ecosystem. And as I said, the way we do it is this, one pillar is the pre-trained models. So people don't even have to do the training. They can just pick up what we did and start using it.
So a startup,
if you have your own,
do that, right? When a startup that doesn't have all the data, they may want the pre-trained model. Yeah, that makes sense.
So for startups, especially, our pre-trained models will be especially attractive because that means that we have done a heavy lift and they can immediately start using it. And then for those that have some amount of data, then we provide the recipes to do the similar type of work on their own data. And then the last piece is when you have done all this training, the models are usually quite large and quite complex. And so you need an efficient way to run it in a production pipeline. And that's the last piece of what we do. And in our work, we talked about it. It's called Jarvis, which is our conversational AI pipeline for actually deploying these models in production.
Got you. So they would work through the models, maybe they use your own or they develop their own, and then it becomes in Jarvis platform, the Nvidia Jarvis platform, which then produces a result. And I imagine you have APIs that communicate with their software
Exactly.
to inform them either to, to fill out the documentation or to fill out the patient record or wherever it might be. Is that right?
That's exactly right. You got it exactly right. And then Jarvis is also free to use, and it's a platform that you can run either on your on-prem data center or on the cloud. But it's ultimately another software solution that we provide that developers can use for free.
Nice. Well, I love that you're enabling this. I think this is the future, right? And it is such a great time that all of these things have brought it together, right? The data's there. Thanks to meaningful use, $36 billion of stimulus money that you experienced at Epic. The processing power is there to be able to do it. We have the storage, we have the bandwidth. I mean, it's such an exciting time. So thanks for sharing these perspectives and kind of the discoveries of NVIDIA on this. For people that want to learn more about NVIDIA and also to learn more about the research, where can they go?
I would just say Google NVIDIA and healthcare. And that will give you the first hit that you get would be our webpage, and you can see all the things that we do around healthcare, including natural language processing and conversational AI.
Awesome. And we'll definitely link to the research and other NVIDIA and healthcare, what you're doing in the show notes, if you will, and in the article. So thanks so much for sharing these insights, and thanks everyone for watching. If you want to find more great healthcare IT content like this, be sure to check it out at healthcareittoday.com. Thanks, Raghav.
Thank you, John. Thanks for having me.